Measure phase, section overview and objectives. By the end of this phase, you will learn what are the different process definitions, what are Six Sigma statistics, how do we perform measurement system analysis, how do we calculate process capability, process definition, section overview and objectives. By the end of this session, you will learn what is cause and effect and the fishbone diagram, what is process mapping, SIPOC, and value stream mapping, what is an XY diagram, what is a failure mode and effect analysis, cause and effect or the fishbone diagram. Cause and effect diagrams are effective team-based tools to determine the potential root causes of a problem. A cause and effect or fishbone diagram breaks problems down into bite-sized pieces, displays many possible causes in a graphic manner, is also called a cause and effect 4M or Ishikawa diagram, shows how various causes interact, follows brainstorming rules when generating ideas. A fishbone session is divided into 3 parts: brainstorming, prioritizing, and development of an action plan. Identify the problem statement and brainstorm the categories in a fishbone diagram. To prioritize problem causes, polling is often used. The 3 most probable causes may be circled for the development of an action plan. Generally, the 4M, that is manpower, material, method, and machine version of the fishbone diagram will suffice. Occasionally, the expanded version must be used. In a laboratory environment, measurement is a key issue. When discussing the brown grass in the lawn, environment is important. A 5M and E schematic is shown in the figure. In the figure, you will also observe that the problem statement, the eye of the fish, has several bones such as measurement, material, machine, method, manpower, and environment. Example. Here is an example of a fishbone analysis for high turnaround time, or TAT. As you can see in the diagram, the possible root causes categorized under methods are staffing, training, approval, processing, and escalation. The categorization under people includes inadequate staffing, inadequate skills, lack of experience, lack of process knowledge. The categorization of measurement includes collection consistency and CTPs not measured. The categorization under Mother Nature includes day of the week of the month of the year, and holiday season. The categorization under materials includes lack of documentation, lack of knowledge base, and lack of escalation matrix. And the categorization under machine includes server downtime and workstation downtime. Measurements of process inputs and outputs can be used to optimize the process being measured. Process inputs may be raw materials, human resources, or services. All inputs have some quantifiable measurement, including human effort and skill level. Process input requirements should be stated so that key measures of input quality can be controlled. Measurements within the process can also be used as effective controls. Once process capabilities are known, output measures can be used to monitor if the process has remained in control. See Figure 2.1. In this figure, the process starts when upstream process provides the inputs that are processed for outputs to the downstream process. Process database of the organization has details of input measures, process controls, process measures, and output measures. Feedback from downstream process measurements can be used to improve an upstream process. For example, electrical testing for solder shorts can be used to optimize a circuit board soldering operation, even if it is several processes upstream from the testing operation. When considering the entire organizational feedback system, complex interrelationships are likely to exist. This is where planned experimentation and designing for Six Sigma comes into play. Planned experimentation deals with isolating the effects of several different independent variables on a process. Designing for Six Sigma includes eliminating potential sources of error. SIPOC. A key concept in Six Sigma methodology is the SIPOC high-level process map, in which SIPOC stands for suppliers, inputs, process, outputs, and customers. This diagram identifies major core processes. Refer to Figure 2.2 below. The advantages of using an SIPOC model include a display of cross-functional activities in a single, simple diagram, a big-picture perspective to which additional details can be added, a framework applicable to both large and small organizations. As you can see in the diagram, the suppliers provide inputs which are processed as outputs and received by the customer. The feedback is shared when inputs and outputs are provided. Similarly, the knowledge repository is updated with the process details. The ultimate goal is to identify essential workflows and sources of variation in work overtime. The diagram can also be adapted to a number of essential support processes. SIPOC captures the key components of success from suppliers through internal processes and onto key customers. Other tools such as process mapping, flowcharting, and affinity diagrams can be used to further identify the major steps in a process or system. SIPOC. The SIPOC process map is designed to be a high-level process view with 4 to 7 displayed steps. This is a flowchart viewed at the 50,000-foot level. The map enables all team members to view the process in the same light. Various Six Sigma authors warn against making the diagram too detailed and thereby losing the ability to focus on a Six Sigma improvement project that has a significant reward. As you can see in the diagram, SIPOC is an acronym of suppliers, inputs, process, outputs, and customer. The following steps can be used for developing an SIPOC diagram. Have the team create the process map. The process may have 4 or 5 key steps. List the outputs of the process. List the customers of the output of the process. List the inputs of the process. List the suppliers of the process. As an optional step, identify some preliminary requirements of the customers. Involve the team leader, champion, and other stakeholders for verification. Process mapping, overview. Process mapping is the graphic display of steps, events, and operations that constitute a process. A pictorial illustration which identifies the steps, inputs and outputs, and other related details of a process, providing a step-by-step picture of the process as is. A graphics technique for dissecting a process by capturing and integrating the combined knowledge of all persons associated with the process. It is a team effort and is documented by everyone who contributes to the process and/or is a part of the process. Process maps help characterize the functional relationships between various inputs and outputs. Flowcharting tools. 3 commonly used process mapping tools to create detailed process maps are process flowchart, deployment flowchart, alternate path flowchart. Commonly used flowcharting tools. Process flowchart. As you can see in the diagram, the process flowchart is a regular flowchart of the process. In this example, an individual lifts a receiver, dials a number, it rings on the opposite phone. If the call is answered, we hear a hello, and then we have a conversation, and finally we hang up the phone. If the phone is not answered, we will hang up the phone. Example of deployment flowchart. In the deployment flowchart, a dealer places an advertisement. An agent will initiate a call, and the buyer will answer, will discuss the details, agree on the details, and then hang up. Similarly, the agent and buyer discuss further. There is an agreement, and then a hang-up. We write the contract, and the attorney reviews the contract. In a deployment flowchart, we create a flowchart using swim lanes, and each swim lane is the role of each individual. Example of an alternate path flowchart. In this example, it is decided whom to call. If we have the number, we dial the number. If we do not have the number, we look up the number in the telephone directory and then dial the number. If the receiver is picked up, we say hello, have a conversation, and then hang up. Likewise, if the phone is not picked up and the voicemail is set up, we will leave a message and then hang up. If the voicemail is not set up, the phone is hung up. Process analysis tools, flowchart and process mapping. There are advantages to depicting a process in a schematic format. The major advantage is the ability to visualize the process being described. Process mapping or flowcharting has the benefit of describing a process with symbols, arrows, and words without the clutter of sentences. Many companies use process maps to outline new procedures and review old procedures for viability and thoroughness. Most flowcharting uses standardized symbols. Computer flowcharting software may contain 15 to 185 shapes, with customized variations extending to the 500 range. Many software programs have the ability to create flowcharts or process maps, although the information must come from someone knowledgeable about the process. Some common flowchart or process mapping symbols are shown below. Process, decision, data, document, subprocess or predefined process, start or end, database, external data, decision or preparation, connector, off-page connector, manual input, extract, merge.